Welcome to the Explainer. Listen, if you're gearing up for the Cambridge 0606 additional mathematics exams, you already know that applying differentiation to practical maxima and minima problems is pretty much the ultimate test. It's a high-stakes scenario. It is the exact moment where candidates either secure those top-tier marks or completely lose out simply because they misread the underlying expectations of the paper. Today, we are diving deep into the source material to decode the exact playbook that principal examiners use to grade these crucial problems. Think of this as your strategy session. We're going to look at what it actually takes to stack the deck entirely in your favor and truly understand what the examiners are hunting for when they grade your paper. Let's get into it. Okay, let's quickly outline the cognitive roadmap for today's masterclass. We've got 5 main areas to cover. First, the maximum minima challenge. Second, the strategy reveal. Third, the method mark transformation. Fourth, the procedural framework. And finally, we'll wrap up with the top 3 examiner traps. Section 1. The Maxima Minima Challenge. Let's dive right into the core of the issue. To really understand the challenge here, the source material highlights 2 very common student archetypes. First, we have Alex. Now, Alex is essentially a human calculator. Alex provides pages and pages of flawless algebra, but absolutely zero context. Then we have Sam. Sam is the sprinter. Sam rushes through the text, misses the command words, and solves for a minimum when the question clearly, explicitly asked for a maximum. This brings us to a really absolutely crucial question. Why exactly do students find applying differentiation concepts to unfamiliar practical contexts so incredibly hard? Look, you know that setting dy/dx equal to 0 gives you a stationary point. That's basic. But the sources emphasize that top-performing candidates don't just memorize formulas. They exhibit a deeply connected conceptual understanding. When the context is an unfamiliar word problem, say about the surface area of a cylinder, rote memory just completely shatters. You actually have to understand what that derivative represents in that specific physical reality. It's about bridging the gap between abstract numbers and the real world. Now, take a look at the transformation right in front of us. On one side, we have this flawed, raw math approach that is so typical of those archetypes we just talked about. What did they do? They set the derivative to 0, they found an x value, and then they just stopped. They literally just put their pen down. They didn't prove if it was a maximum or a minimum using the second derivative. And worst of all, they didn't even answer the actual question being asked. Now, look at the other side. This is your top-tier, context-specific evaluative answer. Notice how those brutal red marks transform into brilliant green check marks? That's because this candidate actually justified their decisions with hard evidence. They showed the second derivative test. They substituted the value back into the original volume formula. And they explicitly stated the final dimensions with the correct units. They didn't just do the math, they solved the practical problem that was put in front of them. That is the difference between a pass and a top grade. Section 2. The strategy reveal. Let's pull back the curtain on how you're actually being assessed. The syllabus is very clear. It demands that you hit 3 distinct cognitive domains to claim the highest marks. It's like a checklist the examiner is holding. First up is knowledge and understanding. Simply put, can you differentiate the function correctly? Do you know the mechanics? Second is application. Can you take that specific derivative and apply it to find the stationary point of this specific real-world object? And third, the absolute holy grail of the exam, analysis and evaluation. Can you prove its nature? Can you recommend the final dimensions based on your findings? Let me be blunt. Rote knowledge alone will leave you stranded at a middling grade. It's just not enough. You absolutely must hit all 3 of these domains to truly master the paper and grab those top marks. So, you might be wondering, how do we actually structure an answer that hits all of those objectives perfectly? Well, the sources point directly to the Peel framework. Point, evidence, explanation, and link. Now, in a math context, your point is explicitly identifying what needs to be minimized or maximized right out of the gate. Your evidence is the rigorous differentiation and equating it to 0. Your explanation is verifying the nature of that turning point, usually using the second derivative test. You have to explain why it's a minimum or maximum. And finally, the link is connecting your numerical value back to the physical context of the problem with the right units. The next time you look at a past paper marking scheme, I challenge you to spot this exact framework. It is literally the DNA of a perfect answer. If you use it, you're playing the game exactly how the examiner wants you to play it. Before we continue, subscribe to our YouTube channel, AC Exams, at @ACExams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 3. Method mark transformation. This is where we talk about how you actually accumulate your score. The underlying strategy of the 0606 exam is crystal clear. Marks are heavily, intensely weighted toward demonstrating systematic processing and the correct procedural sequence. I need you to really hear this. If you just scribble a final numerical answer at the bottom of the page, even if it is 100% perfectly correct, you're going to lose almost all the points for a 6-mark or 8-mark question. Why? Because the examiner can't see your brain working. Clear step-by-step working is absolutely non-negotiable for maxima and minima problems. To put it simply, the process is the product. You are being graded on the journey, not just the destination. I absolutely love this quote from the Principal Examiner Reports. It says, top-scoring candidates demonstrate evaluative thinking by questioning assumptions and justifying decisions with evidence. Let's do a live, quick mental rewrite of a flawed answer right now to see this in action. Imagine a student writes this: dy by dx equals 2x minus 4. X equals 2. Area is 10. Sounds fast, right? But it's weak. Now let's rewrite it with evaluative thinking. To find the minimum area, we set the derivative dy by dx, which is 2x minus 4, equal to 0. Therefore, x equals 2. To justify this as a minimum, the second derivative is 2, which is greater than 0, confirming a minimum. Substituting x equals 2 into the original area equation gives a minimum area of 10 square meters. Wow. Do you see the massive difference there? That second version doesn't just give an answer. It adds massive method marks by providing context-specific evidence and systematically proving the assumption. It leaves no room for doubt. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4. The Procedural Framework. Let's move from theory into our high-speed interactive workshop. Okay, what we have here is the Mathematics Success Blueprint. It's the standardized, foolproof sequence for processing complex practical problems. Step 1. Deconstruct the command words. Are they asking for the dimensions, the maximum volume, or to show that a given formula is true? You have to know your mission. Step 2. Extract the relevant algebraic expressions from the text. Pull the math out of the words. Step 3. Select the analytical framework, which in our current context is differentiation. Step 4. Execute with clear notation. This is a big one. Use dv by dr, not just a generic dy by dx, if the variables are actually volume and radius. Make it match the problem. And Step 5. Present with correct terminology and units. Skipping any single one of these 5 steps is exactly where candidates die on the paper. You have to follow the sequence. Now, what's really interesting is seeing this play out in real time. Let's look at a quick data scan challenge. Imagine a really complex scenario. A manufacturer is cutting squares from a piece of cardboard to fold into a box of maximum volume. Now, imagine a sample candidate paragraph says this: I found the volume equation, differentiated it to get 12x squared minus 40x plus 25, set it to 0, and got 2 values for x. I plugged the largest x into the volume equation to get the maximum. Okay, think about that for a second. What did they miss? The flaw here is massive. They assumed the largest x value automatically gives the maximum volume. But in the physical constraints of the real world, the largest x might actually be physically impossible to cut from the cardboard without completely destroying the box. Or mathematically, it might correspond to a minimum turning point. They failed to execute the second derivative test, and they completely failed to check the physical bounds of the context. They just blindly crunched numbers. Section 5. The top 3 examiner traps. We're reversing the dynamic now to show you exactly what examiners warn against year after year. Let's start with trap number 1. This one catches so many candidates off guard in a high-pressure environment. Trap number 1 is using the wrong approach for the wrong context. What does that mean? It means applying really complex differentiation tools, like getting tangled up in the product or quotient rule, when a simple algebraic expansion would have saved you 5 whole minutes. Or it's trying to optimize a variable that isn't even the one the question asked about. If you don't understand the physical or practical confines of the problem, like for instance realizing a physical length absolutely cannot be a negative number, you will completely zero out your application marks. And the tragic part, you'll lose those marks even if your underlying calculus is technically flawless. Context is everything. Moving right along to trap number 2. This is perhaps the most easily avoidable mistake on the entire paper. Trap 2. Students forget to check format and presentation. Listen, presentation follows incredibly strict conventions in additional mathematics. It's not just about getting the right answer, it's about how you say it. As we mentioned earlier, if the question asks about area A and radius r, and you just lazily write dy dx out of pure habit, the examiner notices that immediately. If you don't use proper headings, if you drop your units at the end, or if your annotations are just a messy, chaotic scribble across the page, you are literally throwing away essential method marks. You have to secure the bag by communicating your mathematical thoughts clearly and professionally. And finally, we arrive at trap number 3. This is the most devastating trap in the examiner's playbook. The classic mistake is providing generic answers, not specific to the question context. If the problem you are solving is about designing a cylindrical can to minimize surface area, and your final circled answer is just x equals 4, y equals 12, you have completely failed to link the mathematical point back to the given scenario. The examiner needs to see the real-world conclusion. They need to see, therefore, the minimum surface area is achieved when the radius is 4 centimeters and the height is 12 centimeters. Failing to link your math back to the reality of the problem will strictly cap your grade, no matter how good your algebra was. So, what does this all mean? Ultimately, it comes down to evaluative thinking. That is the highest assessment level in syllabus 0606. It demands that you evaluate the alternatives, compare your approaches, and most importantly, provide justified recommendations based on your math. You must proactively question your assumptions, like actively testing whether that turning point is actually a maximum or a minimum, and provide answers that are deeply, securely anchored in the context of the word problem. It's about being a problem solver, not just a number cruncher. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.